Okay, so remember this exterior angle is greater than these individually. Next page, we did an example. It's pretty cool actually. This one was like two big triangles, you know. Sorry, one big triangle and two small ones that add up. Exterior angle for this in here, and then exterior angle for this together with that one. And we just figured out that this one was greater than these two and that one. This one was greater than that one and that one. Or this one's smaller than that one and this one's smaller than that one because of that relationship. Measures, okay, we talked about that. Now we're going to come out here and talk about the angle side inequality. This one's pretty easy, I think, pretty obvious in my opinion. Okay, angle side inequalities. In lesson 4.6, you learned that if two sides of a triangle are congruent, okay, then what happened in that situation? If there was two sides of a triangle that were congruent, it was called an isosceles. And then the angles, remember the angles across them were also congruent. In this situation here, what happens when a relationship exists if they're not congruent? So when these, remember the sides were equal in a congruent triangle, the angles were congruent. What happens if all the sides are not? Okay, what happens to the angles? So we're going to go and examine the longest and shortest sides and smallest and largest angles of a scalene obtuse triangle. So this is a cool part right here. It's kind of obvious. If you have the largest angle, it's across the longest side. And if you think about this one over here, if you find the smallest angle, it's across the shortest side. Okay, so notice the longest side and the largest angle of triangle ABC are opposite of each other. Likewise, the shortest side and smallest angle are opposite of each other. So you can think about this too. So if you know that's the smallest, you know that's the largest. Well, then this would be like the middle one, right? The middle angle, I guess, the one with the middle degrees, has to be across the one that's the mid-length. Pretty cool. I like that idea. So we're going to come out here to these theorems right here and say the side angle relationship in an obtuse scalene triangle are true for all triangles and are stated using inequalities in the theorems below. So here we go. This one, you know the side lengths are different. See that? So now you know this side length, looking at this one right here, is greater, 9 is greater than that side length here, 7. So the angle that this one's across happens to be greater than the one that this one is across from. So if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So it makes sense if you think about this one. Line or side XY, you see XY, is greater than that line or side YZ. So the measures that are across it, the angles across it, are going to also be greater in the same relationship. Now in that situation, if one angle of a triangle has a greater measure than the other angle, then the opposite angle of the greater angle, the greater angle is longer than the opposite side, the lesser angle. I think it makes sense when I read that. But it's basically saying, if you know this angle here is smaller than that one, or vice versa, if this one's bigger than that one, then the sides across are also going to be smaller than the other side or larger than the other side. So go ahead and write that down real quick. Again, the sides that are going to be larger are across the angles that are larger. Same thing here, the angles that are larger are going to be across the sides that are larger. So really the idea is pretty cool, pretty easy idea. So I'll give you a couple of seconds, maybe like, I don't know, a minute to write this down. If one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. I had to read it right, sorry. Okay, let's get ready to move on. Ready? Give you about maybe 10 more seconds. So there's a proof of it. We're going to just stay away from that proof. Okay, so we're going to list the angles of triangle PQR. Okay, here's triangle PQR in order from smallest to largest. So here goes the side lengths from shortest to longest are PR, PQ, QR. Now we're going to go to the angles. Okay, and as far as the angles, well, if we look at these side lengths here, and they want smallest. Which is the smallest side length? 7.5. So across it would be what? Q. So that happens to be the smallest angle. The angles opposite the sides are Q, so we're going to go with that one's first, Q. And then the second one would be, what, 8.8, so across that one would be R, QR. And then across, I guess the longest one would be 9.1, so that should go last, which is P. So we're going to go QRP. So let's do, do you have any questions over that one, guys? That's really easy. It's just like really basic. So let's go ahead and list the angles and sides of triangle ABC in order from smallest to largest. So we're going to list the angles again and sides of triangle ABC in order from smallest to largest. So go ahead and do that one real quick. Copy it down real fast. Okay, so just do a real quick triangle and kind of label ABC in the right vertices, and then put the, I guess, side lengths of 3.7, 4.8, and 7. So we want to go ahead and list the angles and sides of the triangle in order from smallest to largest. So we'll go with the angles first. Which one's the smallest angle? Well, I can't tell right now. What I'm going to do is come back and list the side lengths, okay? So the smallest side would be, what, 3.7? So we're going to go with side length. If you don't mind, I'll go with AC. That one's the smallest. And the one across that smallest, AC, would be angle B. And then I'm going to go with the next side length. And we'll go with angle, I don't know yet. We're going to find the next side length of AB. Side length AB is the second, I guess, smallest, second smallest, or middle one, you can kind of say. That one's across C. Then we'll come back over here. The largest, the longest one would be angle, I don't know yet. But I know it's across, what, CB. And so we're going to go angle A. And there it is. Pretty easy. Not too bad. Going once, going twice. What do y'all think? Do we have any questions there? Am I in the right chat? Am I in the right class? Oh, great. Did I start the wrong class? Oh, no. Okay, move on. Okay, so list the sides of triangle A or FG, triangle FGH in order from shortest to longest. So shoot. Okay, well, the sides again correspond to the angles that are opposite against them or across them. So when it comes to the shortest one, it'll be across the shortest angle or smallest angle. So I don't know that third one there. So what I'm going to have to come out here and do is basically do the 180 minus the sum of these two. So 180 minus sum of these two. So now I know that one's 79. Okay? So as we know that one's 79, we're going to come out here and, again, the directions. The directions say here to go ahead and list the shortest to longest, right? So the shortest angle would be G. So angle G would go first. See that one? And then we'd go to angle H. And the last one would angle F. as far as the degrees measures, right? This is the smallest angle, and the largest angle, I guess. Then regarding those things, across them are the sides that are going to go to be shortest, middle, and longest. So there we go. Across here is FH, check. Across angle H is FG. Last one, F, is across GH, and there she is. That's it. Pretty easy, pretty cheesy. Question on that one, guys? Looking at the chat. Anybody have any questions? Okay, let's go on to the next one. If you have a question, go ahead and ask right now. If you don't have a question, let's start on number 3. Okay, so this one you want to list the angles and sides of triangle W, X, Y in order from smallest to largest. W, X, Y, smallest to largest. I'll give you a couple of seconds to copy this down real quick. So it would help me out if I knew that angle right there. All right. Well, if that one's 90, remember this is the idea. This triangle adds up to 180. If we know this is already 90, then these two have to add up to 90. Remember that idea? So all I got to do is just figure out what's the difference of this one and 90 to give me that one here. So I'm going to go real quick on the side. Go 90 minus 51. This becomes, I have an 8er, 9er, 39. Okay, so that is cool to me. So now I know that's my third angle at 39 degrees. This one's at 90 degrees, and then they want us to go to list this from smallest to largest. So the smallest what angle would be angle X. Then we go to angle W, and then angle Y. Now, again, the sides across the angles are going to go ahead and be in smallest to largest order. So the cross angle X, we have side length WY being the smallest. Across W would be side length XY. Last one over here, cross Y would be WX. Okay, guys, question on that one? I feel like I'm boring y'all super bad. Is it just too easy or what? Cricket. No bueno. Okay, do you have any questions on that one? Which one, Alessandra? I'm boring? Oh, you're killing me. It's all right. A-L. Oh, wait. Let's look at this one real quick. Okay, real world example. Y'all see that? Pretty cool. Okay, an interior designer uses triangulation to create depth in a client's living room. I don't know who would, whatever, I'm sorry. If the measure of angle B is less than the measure of angle A, which distance should be longer? The distance between the two lamps or the distance from the lamp to B? Okay, so this is between two lamps. Or the distance from the lamp to lamp at B to the midpoint of the top of the artwork. So the question is asking, should this length be longer? Or should this length be longer? Okay, an interior designer uses triangulation to create depth in the client's living room. If angle B is to be less than angle A, so they want this one less than that one. Which distance should be longer? What do y'all think? Anybody know how to do this one? Remember, they want this angle shorter, smaller, and they want this one bigger. So the question is asking which side length should be shorter, this one here or that one there. Remember, this is the midpoint of the top of the artwork. I don't know what that means. What do y'all think? Does that help us out with anything? Well, if we look at this length here, wouldn't that have to be the midpoint here also? Pretty cool. What do y'all think? Right there. According to the theorem, in order for angle B to be less than angle A, the side length of the opposite sides of B must be less than the length of the side opposite A. All right? So we want this one, right, to be greater than the one across this one here, or right here. Where is it? Then AC has to be greater than BC. Or I'm sorry, AC has to be less than BC, and BC has to be what? Greater than AC. So BC, where was BC? You see BC and AC. We want BC to be greater than AC. The distance between the lamps must be greater than the distance from the lamp at B to the midpoint of the top of the artwork. So questions over that one? It's just basically putting other words to saying that we want this distance here to be smaller than this distance here. And I guess longer. Going once, going twice, it's all right. It's not too bad in the morning or in the afternoon. It's freezing over there actually. Okay guys, we're going to call it quits there. I think I'm really killing you. So what's going to happen now is you have an assignment on Alex. So on Alex, I named the assignment, the section in the book is 5.3. So it's called 5.3. Guys, it has a due date, like at the end of the month. But I'm going to pick up the grades this week. Okay, the due date, the reason I'm going to do the due date way end of the month, so I don't have to reassign it in case somebody's internet or Wi-Fi is not working today or tomorrow. I don't have to reassign it, but I will pick up the grade this week. Okay, so I'll pick up the grade this week. But I left the due date at the end of the month for the reason I don't have to reassign it. Okay, it just makes it easier for me. But I will pick up the assignment this week. It does tell you when you turn it in. It does tell you all that good stuff. So just make sure you get it done today. That's why I'm giving you time right now to go on Alex to get it done. Do any of y'all have any questions? Anybody would need me to go review anything?